My name is Nicolas Blank. I'm an MVP, I'm a Microsoft Certified Master, and I'm a Microsoft Certified Solutions Master, and I have a long and industrious career in the field of Exchange, and I'll get to that in a second. Firstly, I wanted to put up a contact slide. If you have any questions, then please feel free to reach out to me directly using any of the contact details on the slide. This slide will repeat at the end of the presentation, and it'll also be part of the recording if it passes by too quickly. So what I do, obviously, since I'm doing this presentation, I share about Exchange, Office 365, Azure, and cloud stuff in general. I have co-authored a book about Exchange because I feel quite passionately about Exchange. I've been renewed as an MVP for 10 years, specifically in the field of Exchange. So Exchange has led me to cloud from an on-premises world to a cloud world quite directly, in fact. Since from Exchange, I moved to Exchange Online and then into Office 365. I also helped build a number of hosters that led me to the field of infrastructure as a service, and that, strangely enough, led me to Azure. And needing to move to Azure, I was exposed to Azure Site Recovery, and that is what this session is about. I've also authored a course on Pluralsight about Azure Site Recovery, which takes the infrastructure as a service migration and disaster recovery into great detail. In today's presentation, we'll introduce Azure Site Recovery. I'll walk through a number of use cases and then provide a demonstration. Now, the use cases I'll cover very lightly since there are multiple use cases. However, the one that we're interested in is disaster recovery as a service with specific emphasis to move to Azure. So what is Azure Site Recovery? And Site Recovery is a little bit misleading because we do more than that. We start off with being a data center to data center replication as well as failover mechanism. I can also use that for data center to Azure. So again, replication and failover. I can also, let's assume I started off with another cloud provider like Amazon Web Services or Rackspace or any of the other IaaS providers that are out there, and I want to move, or even from my own hoster to Azure. How would I do that? Again, I can use ASR as that replication mechanism. Now, as compared to a lot of storage replication mechanisms, ASR specifically replicates the entire machine at a block level, including the configuration items, with a replication period as low as every 30 seconds. I'll talk about this towards the end of the presentation. However, we can also use ASR as a migration tool to Azure, and specifically we have migration support built in. This allows me to take a given workload, whether it be physical, virtual is VMware on premises, Hyper-V on premises, or virtualized other, such as virtualized on KVM or virtualized on AWS, and migrate it directly to Azure. If I consider Azure as a staging mechanism, let's assume I'm using a hardware refresh as an event to move my data. I can move from on-premises to Azure, change my hardware, and then migrate back to bare metal hardware. That allows me to effectively do a very large data set upgrade, such as a large SQL server, without necessarily suffering much downtime. Bear in mind that I'm able to replicate every 30 seconds at a block level, as I mentioned earlier. I'm also able to fail over very quickly and then fail back or replicate back as fast as physics and my networking will allow. With disaster recovery as a service in Azure, we are provided with a compute platform, a networking platform, and a licensing platform all in one. I don't have to go to different vendors. Within that, I have a number of disciplines, including failover, failback, and DR testing. DR testing is something that, from a managed failover point of view, especially within a DC1, DC2, or live and DR data center failover scenario, we have to do regularly to pass our compliance scenarios. Now, Azure supplies this out of the box. I'll do a demonstration of that in a little while. Now, because we're talking to the PaaS Cloud group, I wanted to call out that we specifically integrate with Oracle Data Guard and SQL Always On. Now, that means we have specific support for both of those scenarios. To illustrate this in a graphical way, I've pointed this out in 5 scenarios. Now, I've shamelessly ripped this slide off from TechNet in order to demonstrate this. So if you're looking for the originator of this, you'll find this on TechNet and, of course, in my presentation. So looking through the various scenarios we have here, we can use ASR as a replication broker for scenario number 1, scenario number 2, and scenario number 4. However, we don't necessarily care for replication brokers in this sense. We care about Azure being a replication mechanism for Hyper-V in scenario number 3, and VMware or physical machines, or as I mentioned, something else that could be KVM based, virtual box based, or effectively anything that allows an operating system to install an agent onto to replicate to Azure. Now, replicate also implies that I'm able to fail over and migrate. So in this presentation for today, we care about scenario number 3 and scenario number 5. Now, before we ASR, we plan. I like to think of Azure as a whole, so Azure's infrastructure as a service specifically as an empty rack. So those of us who have done data center planning know that when we approach a data center, we approach a rack, we have a whole bunch of planning to do. And Azure effectively is that. It's an empty rack with a top of rack switch, and I need to plan for absolutely everything. So while Azure does do a lot for me, it doesn't do everything. I still need to take into account that I need to define my recovery point objective and my recovery time objective. Obviously, that has a massive replication impact in terms of how often I replicate, and one of the big things that we care about here is application consistency versus crash consistency in our application. I'll demonstrate that in the portal in a little while. In terms of storage, nothing is for free. I have to define a storage account. However, every storage account in Azure has a limit in terms of how many IOPS it supports. I also need to consider if I'm using normal storage, premium storage, which is SSD based, or if I'm using managed storage. We have recently changed from a 1 terabyte limit on source LUNs. So these are the disks that are attached to the physical or virtual machines that we're trying to replicate to Azure. We've changed the limits from 1 terabyte per source LUN to 4 terabytes. Now, this was an Azure limitation because previously an Azure virtual machine could only support a 1 terabyte LUN as a target. We also support managed disk support. Now, that means I can take a source VM or a source physical machine, irrespective of the size, as long as it's supported, and I can transform it to a virtual machine in Azure that uses managed disks. Managed disks very quickly allows me to ignore a lot of my storage planning in terms of having to allocate a storage account, think about how many IOPS I need to balance within that, etc., and use a number of defined disk sizes, and Azure effectively does the rest for me. Now, with that, we need to consider capacity planning. Capacity planning in Azure includes things like how many networks do I have? How many virtual cores can I use in a given subscription? And if I'm using more than the default, so normally more than 20 in a given subscription, however, I'm trying to replicate 40, 60, 80, or hundreds of virtual CPUs, then I need to make that call to support relatively early. Otherwise, during my failover testing, everything's going to fall to the floor. Networking is massive. Obviously, we're replicating from somewhere to somewhere, and that requires bandwidth. Now that bandwidth and how much bandwidth I've got available, as well as how I get to Azure, has a direct impact on the RPO and the RTO that we spoke about earlier. If I don't have enough of that, if I don't have dedicated connectivity, be that a site-to-site VPN, which is potentially had quality of service applied to it, or even ExpressRoute, then I may not have the physics required to live up to the RPO and the RTO that we defined earlier. I mentioned earlier that approaching Azure is very much like approaching your empty rack with a top-of-rack switch. When we fail over into Azure, we need to consider that we need an IP addressing scheme to fail over into. With that, we need to know what are the IP addresses that our virtual machines will have when we fail over. We can approach this via a stretched subnet, which is my least favorite option, or a dedicated failover subnet, so that the virtual machines will effectively wake up with a planned IP address scheme in a new subnet, which is also routable back to the network that's on premises. With that, we have some other considerations, such as name resolution and DNS. If I have a Microsoft heavy workload, then I may want to plan by placing a domain controller into that subnet on a permanent basis, so that when my virtual machines fail over, DNS is already set to resolve via my domain controller and know how to authenticate to the world around it. In terms of capacity planning, there's a lot of documentation, and Microsoft has given us some planning tools. So I have listed the two, which is the Azure Site Recovery Capacity Planner and the Deployment Planner, as links in this presentation. So we've walked through a bunch of slides. Slides are always exciting, but demos are more exciting. In this demonstration, I'm going to focus on how to get started with Azure Site Recovery from nothing. I've created a bunch of objects and I'll explain those objects as we walk through the presentation. We'll speak about how to use Azure as a disaster recovery destination, as well as touching on how to use Azure Site Recovery as a migration mechanism. What we're looking at here is we're looking at my Azure dashboard. Within that, I have a recovery services vault that I've predefined. I have a number of virtual machines, and I have an empty resource group. Now, to demonstrate that this resource group is empty, I'm going to click into it, and we can see that we have a destination network. Now, that destination network is quite important, since when we fail over, either from a planning point of view or from a live point of view, we want to have done some address space planning so that our virtual machines know where they are going. So let's go have a look at our recovery services vault, and let's have a look at how we would start from absolute zero. Now, I've created this services vault, and within that I have a bunch of objects, and you'll notice that right at the top I'm able to click plus on backup and click plus on replicate. Now, obviously this is very exciting and I'd like to do that as quickly as possible, but I've got some prerequisites. And this is where Azure is really, really kind to us, because they provide this great section under getting started. Now, if you click plus on replicate for the first time, depending on what you're trying to do, Azure will actually tell you to back off and come back to the same place. So by clicking on getting started on site recovery, we're not losing anything. Looking at our preparation, in this scenario, I'm looking at moving from on-premises to Azure as a destination, either using DR as a service as our service modality, or even looking at Azure Site Recovery as the migration mechanism to move to Azure. And we can achieve both in this screen. Let's have a look at what happens when we prepare infrastructure. So first of all, Azure asks us the obvious. Where do we want to go to? And my source here is on premises. in the next little while, we will be able to move from one Azure region to another Azure region, which is quite exciting, which allows us to migrate from one Azure data center to another data center, or even use another copy of my entire workload and replicate that to another geography altogether. So we're starting from on-premises and we want to move to Azure. We are ignoring the data center to data center recovery broker. However, this is the same place where we would set that up. Then we answer the question if our machines are virtualized. Now, if we're starting with the Hyper-V, then life is great because I install an agent on the Hyper-V host, and after that, a lot of magic occurs since a Microsoft product works really nicely with other Microsoft products. If I'm virtualized with VMware or I'm not virtualized, in other words, I'm using physical machines or another hypervisor, then I have more work to do, in which case I need to deploy extra hardware. So in terms of the preparation, I need to deploy a configuration server. And again, this is all very intuitive. So I would click plus on the configuration server. I would download the bits required to a virtual or physical machine that's in the same network location as the rest of the workloads. And I would do a number of configuration items, such as I would configure the various credentials required to replicate my Windows or Linux or Unix workloads up to Azure. I already have one of those configured, so I'm going to choose to use that configuration server and move over to my target preparation. Now, here we're able to move to a number of things, including different sponsorships, different subscriptions. We can choose the deployment model that we're going to use after failover. Now, here we can use Classic or Resource Manager, bearing in mind that most of the ASR functionality which I'm talking about, well, actually all of the functionality which I'm going to speak about is deployed in the Resource Manager. However, some legacy bits and pieces are still in Classic. I would recommend that you adopt Resource Manager as quickly as possible and even consider moving from Classic to Resource Manager. But I think that's a topic for another webinar. We need to land our storage somewhere. So we need to consider that we need Azure storage that's available and that we have a compatible virtual network. So I've got a bunch of those, and I'm going to configure where I'm going to write those virtual machines to. Next, I need a replication policy. Earlier we spoke about an RTO and an RPO. Now, a lot of these are quite self-explanatory. If Azure is unable, or Azure Site Recovery Services is unable to meet the RPO that we define, it'll let us know. I can also choose to define my recovery point retention in hours, as well as how often I take an application consistent snapshot. Now, earlier you heard me say that I'm able to replicate down to as fast as every 30 seconds. That doesn't mean that I'm application consistent down to every 30 seconds. Now, those of us who are running in the Windows world for a while will remember that application consistency is achieved using VSS, and VSS isn't free. VSS allows us to create an application consistent snapshot of the host or the application which is VSS aware within that host and hand it off to a backup requester which is asking for that snapshot. Now, obviously that's not free, and I'm not going to do that every 30 seconds. However, the implications of that will be shown later when we choose how we're going to fail over and what we are failing over. I have created a replication policy here, which is Active Directory plus SQL, and I'm going to hit OK. Now, obviously, there's some deployment planning, and this is basically the don't run with scissors step. Have we done our deployment planning? And I'm going to say, yes, I have. So I'm going to lie shamelessly and hit OK. So now that I've done that, I've prepared my infrastructure. In preparing my infrastructure, I've deployed a configuration server that allows me to connect to the physical or virtual machines, depending on what my sources are, and install agents onto those. I can authenticate to those and then start replicating those up to Azure, which is the next step we're going to have a look at. So next, I'm going to choose that I'm going to replicate a workload up to Azure. We have defined our source. Now that source there is the configuration server that we've deployed on premises. That is cunningly called Demo ASR1, and I can see that it's a configuration server. Now this label here for VMware applies to physical and VMware workloads alike, and if you browse through the documentation on docs.microsoft.com, you'll notice that physical and VMware are treated very much in the same way, effectively because the steps are the same. We deploy a configuration server, we deploy agents on each of the machines that we want to replicate, and then we replicate them. So here my machine type is physical machines, and I have a process server, which is the same as my configuration server. However, if I need to split those out, I can split those out for the sake of scaling out my workloads. Next, we need to answer some questions. Now, we've spoken about I need a subscription to land in, I need a resource group for my resources to land in, and I've chosen my deployment model. Obviously, I need some storage, and I've chosen a storage account that I've configured for this purpose. And I can also choose a bunch of networking options. Now we have many networking options, and these are some of them. So I can choose to configure this now for selected machines and choose to arrive in this network on this IP address scheme. And with no further work, the magic of DHCP will allow these machines to find themselves with an IP address after they boot up and have that IP address. So let's go with that for now. And we're going to choose the machine that we want to replicate. In this case, I'm choosing a machine called NBC Demo Victim. It's a Windows machine, and this is the IP address at source. Now I can configure a number of properties. Earlier we spoke about storage, and here I can choose which disks or LUNs are included in my replication set and which I'm going to leave behind. Obviously the OS disk is mandatory. However, I can also choose if I have disks that are larger than 4 terabytes to leave those behind. That may break my application, and obviously that has to be part of my planning. I can also configure a bunch of credentials. And here you can see that I've rolled out a number of credentials for several machines that I have deployed. I have a domain admin type of account, so a service account which has access to every machine within a domain. However, I may have local credentials configured for a particular machine, which I can define as well. I have a Linux root and an Oracle admin for a Ubuntu and Oracle machine respectively. So I'm going to choose my local credentials, hit OK, and then look at my replication settings. Now these should look familiar because we've examined them at the replication policy earlier. Note that this is not the time to define a replication policy, only to consume one. So within that, I have an RPO threshold of every 15 minutes. So if Site Recovery cannot do something within 15 minutes, cannot replicate, then we'll have an alert. The recovery point retention and the application consistent snapshot frequency is also familiar. Now, what if I have multiple machines that I want to group together for the sake of failing them over together? Classic examples here would be an application and a SQL server potentially thrown in with a domain controller. Now, I can enable multi-VM consistency really simply by creating a new replication group. And I've got one of those, and I'll show that to you in a later step. For now, I would be able to define this group, choose which machines I'm going to have as part of that group, and then hit OK. And Azure Site Recovery would do the rest for me. For now, I'm going to choose to replicate a single machine and hit OK. With that, we'll hit Enable Replication, and we'll notice that at the top, I have a notification which tells me that the operation is in progress. I'm able to monitor that as well by looking at my vault and seeing what happens inside my vault as well. So let's move back to my vault, and we can have a look at the operations which are currently in progress. Here I can see the view of my vault, and vault includes the ability to replicate as well as backup. For today, we're going to pretend that backup doesn't exist, and we'll just have a look at what's happening with site recovery. So I can see that I've got a number of site recovery jobs. I've got one that's in progress. You can see things I've done beforehand and if they were successful or failure. Let's have a look at what happens when we enable replication. We can see that there are a number of steps which are documented fairly well. At the moment, we're pushing an agent out and preparing the target. There would have been some prerequisite checks in terms of, can I log in, can I ping the machine, can I reach it remotely in order to push the agent out. Any one of these, if they are absolutely important to me, I can pin to the dashboard. None of them are too exciting at the moment, so I'll close that. And I'll have a look at the rest of the items that I've got available in my vault. We can see that I have got a number of items available, and I can also see that I have a current status of enabling protection on the victim virtual machine. Now I have a fairly large Oracle virtual machine. This machine is running a Oracle database natively running on Oracle Unix, and I have all the capability on this machine that I have on a Windows machine. In order to demonstrate that, I'll show you that I can change the recovery point. I can commit this machine, I can complete machine, or I complete migration, reprotect, resynchronize, and disable replication. These only have context a little bit later on in this demonstration, so we'll come back to them. For now, we'll have a look at what do I do when I need to do DR planning. So we spoke about disaster recovery as a service and being able to enforce my compliance requirement of being able to test my disaster recovery and see if my disaster recovery scenario would actually work or not. In this case, I'm going to have a look at the settings I've got available, and I'm going to choose the test failover action. So when I do a test failover, I'm able to choose what I want to failover from. Now remember earlier we spoke that we have a replication cycle which is not necessarily the same as my application consistent cycle. So I could choose the lowest possible RPO. I could choose the latest consistent processed low RTO recovery object, or I can choose the latest application consistent snapshot. Now application consistent means that my logs are committed, my application is healthy, and all going well, this machine should come up as if it did come up from a cold start. So I'm going to choose my latest application consistent snapshot. I need to choose where this machine is going to land. Now remember earlier we spoke about the network planning. So I'm going to choose the virtual network which this machine is going to wake up in, and I'm going to hit OK. Now recovery services will warn us that since we're doing a DR failover test, we don't necessarily want to use a live production subnet. And the reason for that is quite simple. Because when we do a test failover, this machine will actually be created somewhere. All the resources for this machine will be staged, the storage will be staged, and this machine will boot. And as part of our recovery testing, we're able then to log into that machine, check if the application is healthy, and then decide if we're going to declare the test successful or not. All of that is included in our recovery steps. Now imagine if this is a copy of a live machine such as a database or a domain controller or a DNS server, and it wakes up in a live subnet, and very quickly we could consider such disasters scenarios such as split brain. Now in order to prevent such a scenario, Site Recovery has built in that we're able to deploy and stage in a completely disconnected environment. However, within that environment, we can do whatever we want to. So to demonstrate this, we'll move back to our dashboard, and we'll move back to the resource group that we've chosen as our landing destination. And we'll notice that in a little while, these resources will start landing. So here we can see that I've got an NSG that started landing, and very quickly other objects will land as well. Now within this, I can then, depending on how I've networked this subnet, I can connect to it via my site-to-site subnet, or I can declare an external IP address for this machine and connect to it in absentia of the rest of my networking configuration. So here we can see this machine is landing. Now this is not a small machine, it's an SSD-based VM, and it includes a relatively large Oracle workload. So we're going to let it fail over. While that's failing over, we'll move back into our vault and we'll have a look at some configuration items. Now, even though this machine is failing over, I'll touch this machine and have a look at my compute and network properties for the replica that is existing in the vault. We spoke about planning earlier, and within this, I'm able to plan what happens should this machine fail over. That could be a planned failover, and planned failover could include a migration step or be part of a migration. It can be an unplanned failover, so the physical machine or the physical location in which it exists doesn't exist anymore. Within that, I can then choose when it lands, how big is it? In this case, I can scale the machine up or down as required. So irrespective of what it is when it started to replicate, I can say when you fail over, you will be the following size, should my budget allow it. I can also choose how my storage is set up if I'm going to use a as close as possible replicated subset of LUNs. So effectively, whatever size my LUNs are on premises is what they'll be in Azure. Or I can use managed disks, which means I'll automatically be sized to the largest managed disk that is closest to the source size or the size of the source LUN. Lastly, I can also choose, if I've got multiple subnets, which subnet I'm going to land in and what my IP address will be as soon as this machine fails over. Now, these settings can be honored during the failover testing as well as actual failover. This is something that adds an incredible amount of value to us as administrators when we consider failing over and doing our disaster recovery planning and planning our what-if scenarios. Disaster recovery, especially when we do our DR tests for the first time, isn't something that necessarily goes smoothly all of the time, nor should it be expected to, since we have a hint in the name of being a disaster. Now, being able to do disaster recovery planning and testing in a predictable manner absorbs a huge amount of pain from us. And we can see that ASR makes these type of features available. Let me close this screen and let me talk about the actions which we spoke about earlier. Now, when I do a failover, I can choose to, before I hit commit, I can choose to change my recovery point. So let's assume I'm doing a failover, my virtual machine now exists in Azure, and I've closed or shut down my source machine. I can poke at it. I can log into it, I can have a look at the state of the virtual machine, I can decide that the state is unacceptable and I want to move to another recovery point. I'm able to do that as part of the workflow in Azure. When I'm finally happy with that, I can hit commit. Commit allows me to stop replication from source to target and declare that whatever is now sitting in Azure is authoritative. Now, we may consider that a migration, but it's not, in which case we want to hit complete migration. Now, complete migration will do everything we've spoken about in commit, as well as stop the licensing of Azure Site Recovery. Why would I be doing this? Say, for example, I'm moving from one Azure region to another, or I'm moving from one cloud provider to another. If that's a migration versus a disaster recovery replication exercise, then I'm going to do it once and then I'm going to choose to complete migration. I have options to reprotect. So I would want to protect from either source to target or target to source. And I would potentially wish to resynchronize should replication break for any reason. I also have the option to disable replication and take this machine out of the Azure Site Recovery replication set, which also decrements the licensing implications of that. So we can see that I'm at 0% synchronization for my victim, and I am initiating a test failover. I can refresh that periodically to get an update on that. And otherwise, we have covered as much as we can in a high level without drilling down into extra aspects of Azure Site Recovery. With that, I'd like to go back to our presentation and open us up for questions, should there be any.
All right. Thanks a lot, Nicholas. At this point, we don't have any questions. I give it a couple seconds though for people to type in if they've got one.
While we're waiting for questions, I'll put up the contact details slide again. So if you do have any questions that pop up later, then feel free to write me or tweet me at the details that you see on screen.
It appears that we don't have any questions at this time. So with that, I think I will just close out the webcast here today. And thanks again for presenting in this time. I know this is one of the times that PASS is really looking for us to start providing more presentations for folks around the globe to make sure that not just the U.S. gets the nice, comfortable hours for webinars through the PASS organization. Oh, looks like we did get a question. Let me just open this up so I can actually see it. Super tiny here. So got a question here. Hi, when you fail over VM, how would you bring SQL Server to the same level with the VM?
I'm not quite sure I understand the question. So are we talking about application consistency of SQL within the VM? Or are we talking about SQL as a target of SQL replication?
I'll give them a moment to clarify. The first one.
Okay, so I've got a bunch of choices. Now, you would have heard me talk earlier about I can replicate as fast as I want to, so that could be every 30 seconds, but that's effectively crash consistent. Or I can push this down to as much as ASR allows. I can replicate in an app consistent manner. So I can choose that I want to replicate from an app consistency point of view, or I can be crash consistent. And crash consistent is as fast as you're willing to run from a replication point of view. Now, SQL, like Exchange, is fairly resilient from a logging point of view, so I don't think that failing over, particularly if it's a disaster from a crash consistent point of view, is the end of the world. So the quickest that you can fail over is, assuming physics is with you and networking allows it, is anything up to 30 seconds from source.
All right, and the reply is thanks.
Fantastic. Thank you very much.
All right.
Cool. Thanks, Nick.
Yeah, thanks again, Nicholas, and look forward to actually having you join us again, and hopefully having a giving you an opportunity to present on some other topics.
Yeah,
with that,
I'm very keen to.
All right. With that, I'm going to close everything out here, and everyone enjoy the rest of your day.